one of the more challenging limits when you're getting used to evaluating limits is dealing with this rationalization problem. So rationalizing the numerator and denominator is something that you probably did in pre-calculus and you probably didn't spend a lot of time caring about because it felt like a chore. And when we deal with limits, what you find is that rationalization is going to come in handy here. So what I want to do is do a quick review. So if we talk about this idea of a conjugate, if I have some number plus a square root, its conjugate is the same number minus that square root, and vice versa. If you start out with a negative square root or a negative outside the square root, its conjugate is this. So conjugates come in pairs. So just remember that. The second thing I want you to remember is this difference of squares formula. Remember that a plus b times a minus b is a squared minus b squared. Similarly, if I have two conjugates and I multiply those together, I get a squared minus, I don't get b squared, I get b because it's the square root of b squared. So, and this, again, this assumes that b is a positive number. Technically, you can have zeros inside a square root, but if you do, you don't really have conjugates. And then a can be positive or negative. So, given that idea, we can go, let's take a look at an actual limit. We have a limit, we have x plus 5 minus 3 over x plus 4. So, to do that limit, one moment. That's not the limit that I meant to do. Those have to change. Why does that have to change? Well, if it doesn't, then we get a limit we don't need to use this technique on. So, sorry. So if we plug in forward by direct substitution, and again, you should always try direct substitution first. Always. Because you could spend a lot of time on techniques when you didn't have to do that. Always try direct substitution first. So trying direct substitution, I get square root of 9, which is 3, minus 3 is 0, over 0. So I get an indeterminate form. So since I have an indeterminate form, I have to use some other technique. So if we're going to use the rationalization technique, there's a 6-step approach. And again, it's not guaranteed to work. But for what we're doing, it probably will work most of the time. So given that, what we're going to do is we're going to follow these techniques. We're going to say, all right, first thing is to find the conjugate. So in this particular case, what I find is my number is not this piece, it's actually negative 3 plus that. So that's my regular one. But my conjugate then is negative 3 minus the square root of x plus 5. So I'm going to rewrite this. And then, so this is step 1. Step 2 is to multiply top and bottom by the conjugate. And that's not going to be an issue here. Because if you evaluated the limit of the conjugate, it wouldn't be 0. So you're not multiplying top and bottom by 0. So step 2 is to multiply by negative 3 minus the square root of x plus 5 over x minus 4 times negative 3 minus the square root of x plus 5. So again, that's step 2. Step 3 is going to be to simplify the top. And we can use this formula. Remember, we have this conjugate formula. So that tells me that it's a squared. Well, a is negative 3, so that's 9, minus whatever's inside here, which is x plus 5, all over x minus 4 times negative 3 minus the square root of x plus 5. That's pretty ugly, not going to lie. So that's step 3. really we're still on step 3. Both of these are going to be step 3 because I need to simplify this. So if I distribute the negative and simplify, I get negative x plus 4 over x minus 4. And I'm, for my own sanity, going to pull a negative 1 out of here. So you have the square root of 3, or sorry, 3 plus the square root of x plus 5. Okay, so we're close. I got a negative x plus 4, and I got an x minus 4, and a negative 1 here. So what if I put the negative 1 into here? So I'm going to call that, I'm going to say this is step 4. And this is going to be the limit as x goes to 4 of negative x plus 4. If I distribute the negative, I get negative x plus 4 times 3 plus the square root of x plus 5. Well, now I can cancel the common factors. The limit as x approaches 4 of 3 plus the square root of x plus 5. And then I really just can evaluate the limit. So if I try by direct substitution, I get 3 plus 4, square root of 4 plus 5, so square root of 9. So 1 over 3 plus 4 plus 5. 1 over 3 plus the square root of 9, which is 1 over 3 plus 3, which is 1 over 6. So 1/6 is our answer here. And what you'll find is problems that look like this pretty much always follow this. Again, it's not guaranteed. You could do all that work and it still might not evaluate. There might be other things you have to do. But in general, these are your steps. So try that out on some problems and see if it doesn't work out for you.